Welcome to the Learning Community Innovation Zone, also known as the LCIZ, UConn's first and only makerspace. This 1,500 square foot space is open to all students participating in any of UConn's 30 learning communities. Upon completion of the appropriate safety training, students have access to the equipment, including 3D printers, vinyl cutter, laser cutter, drill press, CNC router table, bandsaw, and hand tools, as well as the textile and electronic stations. Various workshops are also provided to introduce students to new and innovative topics that they may not otherwise get to experience in a traditional classroom setting. Makerspaces, like this one, embrace the maker movement, an educational philosophy based on active learning through doing in a social environment. The maker movement views all students as potential makers, those that design and create for fun and self-fulfillment. By using this informal, peer-led, student-driven model, learning becomes more immersive and relevant. This inspires creative and innovative thinking that encourages risk-taking, innovative design, prototyping, collaboration, problem-solving, and entrepreneurship. Over the past week, I've worked with the Maker Mentors in the LCIZ to learn some basic design skills to complete 2 projects. My first project was engraving a metal dog tag with the UW Husky logo. In order to do this, I used the laser engraver and cutter software only available in the LCIZ. I pulled an image of the UW Husky logo from the internet and placed it onto the dog tag template. Before engraving the dog tag, I used the vector job type to check the laser's path along the edge of the material. I ensured the cutter was set to pointer and the dog tag template and confirmed the laser's alignment. I then went back to the settings and changed the job type to raster. I also used the provided settings for the dog tag to adjust the raster settings and piece size in inches. After closing the lid, the engraver took approximately a minute to engrave the dog tag. My second project was designing and printing a UW on one of the 3D printers. In order to do this, I used the Tinkercad software available for free online. First, I inserted a solid box. I then adjusted its length to 5 centimeters, width to 3 centimeters, and height to 1 centimeter. I did not adjust the radius or steps settings. I then inserted solid text and changed the text to UW. I used the standard font, multi-language. I did not adjust the bevel or segments settings. I placed the text on top of the box and made sure it would stand approximately 3 millimeters above the top of the box. Finally, I checked to be sure the text wasn't going through the bottom of the grid and the bottom of the box was flat. After ensuring the file was complete, I exported the file as an STL, downloaded it to a flash drive, and uploaded it to a computer hooked up to the 3D printer. The 3D printing process turns a whole object into thousands of tiny little 2-dimensional slices, then makes it from the bottom up, slice by slice. Those tiny layers stick together to form a solid object. The 3D printer I used for this project was the MakerBot. The MakerBot uses material extrusion to build the desired object. Material extrusion works like a glue gun. The printing material, in this case a plastic filament, is heated until it liquefies and is extruded through the print nozzle. Using information from the digital file, the nozzle deposits the polymer in thin layers. The polymer solidifies quickly, bonding to the layer below before the print head adds another layer. My project took approximately 40 minutes to print. Although I spent time on the LCIZ steering committee, this was one of my first times working in the makerspace and learning from the students. This experience showed me how easy it is to become a maker as long as you're willing to challenge yourself. Most importantly, I learned the significance of value openness, making peace with imperfection, building a community, and loving what you do.